Hi, welcome once more to Mr. Max. In this lesson, we are going to revise from November 2020 sequence and series questions. Okay, November 2020 sequence and series, that is question number 2 and 3. So listen very carefully. So what is the first question? 2.1. Question number 2.1. What is that question? 7 comma x comma y comma 11 comma etc, and it is given that, look at that question, is an arithmetic sequence. So it is given in the question that this one is an arithmetic sequence. What is an arithmetic sequence means? If there is a common difference, am I right? Look at this another example. I'm going to write another example here. Okay, so not this question. Okay, 3 7 11 15 19, then 23 27, etc. This is another example, no connection with our question. Okay, so here what is the first term? You know that the first term is T1, then this is T2, this is T3, this is T4, fourth term, fifth term, sixth term, seventh term, like that. Am I right? Okay, so here this first term I'm going to write T1 is equal to 3 like this. Okay, T1 is equal to 3. Am I right? And what is the second term? T2 is equal to 7, T3 11, T4 15, T5 19, T6 23. Okay, that's enough. Okay, now what is the common difference? This is an arithmetic sequence, and here what is the common difference? 7 minus 3. I hope you know this one. Okay, 7 minus 3 4, 11 minus 7 4, 15 minus 11 4. So what is the common difference here? In this sequence, the common difference is 4. Am I right? Okay, common difference is denoted with a D. Okay, now this first term is 3 here, and that 3 here, okay, we know that it is generally, we can write it as A. Okay, now this second term 7, I'm going to write it like this: 3 plus 4. What is 3 plus 4? 3 plus 4 is 7. Am I right? Okay, so 3 plus 4, but if I write it like this, there is no problem. 1 times 4, dot means times. Okay, 3 plus 1 times 4, so it is 3 plus 1 times 4 is 4, so 3 plus 4 is 7. Am I right? Okay, then this third term I'm going to write like this: 3 plus 2 times 4. What is 2 times 4? 8. 8 plus 3, 11. So that's fine. Okay, then this fourth term I'm going to write like this: 3 plus fourth term, 3 times 4. So what is 3 times 4? 12. 12 plus 3, 15. So there is no problem. Okay, 19, that is fifth term. Okay, fifth term I'm going to write like this: 3 plus fifth term, 4 into 4. 4 times 4, 16. 16 plus 3, 19. Can you see something there, a pattern? Sixth term 23. So I'm going to write like this: 3 plus sixth term. So it is 5 times 4. 5 times 4, 20. 20 plus 3, 23. So what you can observe here, guys, look at this one. This first term, I can write it like this also. Instead of this A, let me write it like this: 3 plus 0 times D. 0 times any number is 0 times, sorry, not D, 0 times 4. 0 times any number is 0. Okay, that's 0 plus 3, that is 3. Okay, so now what you can observe from here, this 4, this 3 3 3 3 3, can you see that? Okay, that is the first term. Can you see the first term is 3? Okay, and what is this 0 1 2 3 4 5? How can you identify that one? Look, for example, third term, here what I wrote 2. Fourth term, here what I wrote 3. Fifth term, here what I wrote 4. Sixth term, here what I wrote 5. You understand? 1 less than this one. So if it is T10, how can I write like this? 3 plus 9 times 4. 1 less than this 10, that is 9 times 4. Then what is this 4 4 4 4 4? That is our common difference. You understand? So this 3 stands for the first term. This one stands for 1 less than this number. Okay, 1 less than this, 1 less than this, 1 less than this. You understand? And this 4 stands for the common difference. So generally, if it is Tn, let me erase the last one. If it is Tn, how can we write Tn? So generally, how can I write Tn is, this one is first term. So first term normally we represented with the A, am I right? Plus 1 less than this, see 1 less than 6 is 5, 1 less than 5 is 4, 1 less than 4 is 3. Can you see that? Similarly, 1 less than this n, that is n minus 1. You understand? Then what is this 4 stands for? The common difference. So this is how you got the nth term formula. You studied nth term of an arithmetic sequence, that is Tn is equal to a plus n minus 1 into d. Okay, this is how you got that formula. Okay, so anyway, now leave all those things. These are the some theories behind how do you get this formula. Okay, so what I'm trying to explain is, in case in an arithmetic, definitely it must be an arithmetic sequence, then only we can apply like this. Okay, so if you want to find the fifth term, what you have to do is first term plus a plus 1 less than this fifth term, that means 4d. Okay, so generally look at how I am going to write. For example, if I want to find the fifth term, so I can write it like this: a plus 1 less than this one, 4 into d. If I want to find the eighth term, then first term plus 1 less than this one, that is 7d. You understand? Okay, if I want to find the 100th term, a plus first term plus 1 less than this, that is 99d. You understand, guys? Okay, so similarly, now we can come back to our question. So don't forget, we are going to apply that one there. Okay, so now let's come back to our question. What is this question? We have to find the values of x and y. That is the question. Okay, so how can we find the values of x and y? That is what I am thinking. Now let's come back to our question. Okay, so in our question, this is the sequence given: 7xy minus 11. Okay, so let me call this one as first term, this is the second term, this is the third term, and this one is the fourth term. So I already told you, first term normally we represent with the small letter a, am I right? Okay, and this one is fourth term is minus 11. Fourth term, what is the fourth term? T4 is minus 11, am I right? Okay, so T4, it is given in the question, this is an arithmetic sequence. So how can we write T4? Like what I told you before, first term plus 1 less than this 4, that is 3 times common difference. And in this question, we already know what is the fourth term, that is minus 11. Am I right? So instead of this T4, I can substitute minus 11, that is the fourth term. A stands for the first term. What is the first term? 7. So it is 7 plus 3d. So take this minus 7 to this side, so it is minus 7. So minus 11 minus 7 is equal to 3d. Minus 11 minus 7 is minus 18 is equal to 3d. So divide both sides with 3. So what is answer? That 3 cancel, 3 cancel, that is d, and minus 18 divided by 3 is minus 6. So it means that the value of d is minus 6. The common difference is minus 6. You understand? Now we have to find the first term. Okay, so for that, what we can do, we can substitute in the same equation. So here now we have to find the value of this x and y. That is our question. Am I right? Okay, so how to find the value of x and y here? Now look at this one, guys. Here for another example, let me write it here. For example, 2, then 2. Okay, let me give another example. Let's say 15, 11, then 7, 3, etc. Okay, so here what is the common difference? 11 minus 15. Don't subtract 15 minus 11. What is 11 minus 15? Minus 4. Am I right? 7 minus 11, that is minus 4. 3 minus 7, that is minus 4. Okay, now look at this one. How can I get this second term? 15 minus 11, that is 11. Am I right? 11 minus 4, 15 minus 4, that is 11. 11 minus 4, that is 7. 7 minus 4, that is 3. That is how I can find the next term, next term, next term, like that. Okay. Similarly, what is the value of d we got? Minus 6. That means the common difference is minus 6. Okay. So here, what is the common difference here? Now we know that the common difference here, it is minus 6. So how can I find the value of x here, guys? This is 7. Then like this, how do I get this 11? 15 minus 4, that is 11, like that. So how can I find the value of x? 7 minus 6. What is 7 minus 6? That's 1. So it means that the x value is 7 minus 6. So x is equal to 1. So we already got the value of x. Am I right? Okay. Now we have to, x means second term. Okay. Now we have to find the value of y. So how can I find? Now we know that x value is 1. This is 1. Am I right? And what is the common difference? Common difference is same always. Okay. So how can I find the value of y now? 1 minus 6. This term minus, like this. How can I find this 7? 11 minus 4. Similarly, 1 minus 6. What is 1 minus 6? It is minus 5. So, and that is the value of y. So, y is equal to 1 minus 6. So, y is equal to minus 5. And that is the value of y. You understand? Okay. So, that is question number 2.1. Okay. Now, let's move to the next question. Question number 2.2. 2.2. Given the quadratic number pattern. So it is given in the question that the one given is a quadratic number pattern. So what is the number pattern? Minus 3, 6, 27, 60, etc. If it is a quadratic number pattern, you know, you can find the second difference. Okay, and the second difference are the same. So let's check what is the second difference. Here we have to subtract 6 minus 3, 6 minus 3. So it is 9. 27 minus 6, that is 21. 60 minus 27, that is 33. Am I right? Okay. Now 21 minus 9. I'm going to find the second difference now. 21 minus 9. So it is 12. Then 33 minus 21, that one is also supposed to be 12. 31, yeah, 12. So the second difference is 12. You understand? Okay. Now, what is the first question? 2.2.1. First question, 2.2.1. What is that question? Determine the general term of the pattern in the form Tn is equal to an square. You have to find the general term. So what you can do to find the general term? I already explained in the lesson. Okay. So what you have to do? The second difference you have to call it as 2a. Then the first difference you have to call it as 3a plus b. And the given sequence you have to call it as a plus b plus c. Okay. So that structure you have to remember. Okay. Second difference 2a. First difference 3a plus b. And the given sequence is a plus b plus c. Okay. So now starting from the bottom, 2a is equal to 12. What is the general equation of a quadratic number pattern? Tn is equal to an square plus bn plus c. Am I right? That's the general equation. And here we are trying to find the values of these a, b and c. Right. Okay. So for that, look at this one. First you have to say 2a is equal to 12. So what is that one? 2a is equal to 12. So from here, what is a? This is multiplication. So these two on this side, it is division. So 12 divided by 2. So what is that? A is equal to 6. So it means that the value of a is 6. Now we have to find the value of b. Am I right? So for that we can take this equation. What is that equation? 3a plus b is equal to 9. We have to take that equation. Okay, what is the value of a? We got a as 6, so we can substitute here. Am I right? So it is 3 times 6 plus b, and that is 9. So what is 3 times 6? 18 plus b is equal to 9. Take this 18 to the other side. Positive 18 on the other side, it is negative 18. So b is equal to 9 minus 18. What is 9 minus 18? Minus 9. So now we got the values of a and b. Now what is outstanding? A, b we got. Now we have to find c. So for that we can take the third equation. What is the third equation? A plus b plus c is equal to minus 3. What is the value of a? 6 plus. What is the value of b? Minus 9 plus c is equal to minus 3. Am I right? I substitute the values of a as 6. This is the value of a we got. This is the value of b we got. So a is 6, b is minus 9. What is plus 9? Plus minus. Plus times minus is minus. So it is 6 minus 9. Am I right? This is minus. So what is 6 minus 9? Minus 3. Plus c is equal to minus 3. So if I take this minus 3 to the other side, it is positive 3. Am I right? So remaining here it is only c minus 3 plus 3. Minus 3 plus 3 means you can cancel that one. Am I right? So what is the value of c? It is 0. So now we can substitute in this general equation. What is our equation? Tn is equal to an square. What is the value of a? 6. So it is 6n square. Value b is minus 9. So minus 9n plus, what is the value of c? It is 0. So finally we can write once more 6n square minus 9n, and that is the nth term of that quadratic sequence. You understand? Okay, so let me write that nth term once more here. What is the nth term we got? Tn is equal to 6n square minus 9n. Okay, now let's move to the next question. Question number 2.2.2. Question number 2.2.2. What is that question, guys? Calculate the value of the 50th term of the pattern. You have to find the value of the 50th term. Okay, so what is the general equation? Tn is equal to, we got the general equation, 6n square minus 9n. And here what is the question? Simple question. We have to find the 50th term. So what you have to do? Substitute the value of n as 50. So it is T50 is equal to 6 into 50 square minus 9 into n value is 50. So check in your calculator, what is answer for that? 14,550. So it is 14,550, and that is the 50th term. You understand? Okay, so that is question number 2.2.2. now let's move to the next question. Question number 2.2.3. what is that question, guys? Show that the sum of the first difference of this pattern can be given by Sn is equal to 6n square plus 3n. I don't understand anything. What do you understand? Look at that question once more. Show that the sum of the first difference. Which one is the first? This is a quadratic sequence. The given one is a, let me erase this one. Okay. So the given one is a quadratic sequence. Am I right? This one is a quadratic sequence. Okay. Now look at that question once more. Show that the sum of the first difference of this pattern. This is the first difference. Am I right? Okay. So let me write that first difference once more here. 9, 21, 33, etc. This is the first difference. Am I right? Okay. And what you want to show? Show that the sum of the first n terms. Sum of the. Okay. First, how many terms? N terms. of this sequence is given by. So you have to show that the sum of this one is, for sum of the first n terms is Sn is equal to 6n square plus 3n. So now look at this first difference. This first difference, what is the common difference here? If you subtract this one, 21 minus 9, is it not 12? 33 minus 21, that is 12, because this is an arithmetic sequence. Can you see that common difference? Okay, so in a quadratic sequence, the first difference is an arithmetic sequence. You understand? In this is a quadratic sequence. Okay, and in this quadratic sequence, when we take the first difference, that is this one, and that one is an arithmetic sequence. Why it is an arithmetic sequence? Because you are getting a common difference, 12. You understand? Okay, so in effect, you have to find the sum of the first n terms of this arithmetic sequence. You understand? What is the formula to find the first n terms of an arithmetic sequence? We studied the formula for to find the sum. Sn is equal to, what is the formula? You have to by heart, n by 2 into 2a plus n minus 1 into d. I hope you know this formula. Okay, you have to by heart this formula. Okay, n by 2 into 2a plus n minus 1 into d. So this is the formula that we can use to find the sum of the first n terms. Don't forget. So leave this n as it is. Okay, so Sn, therefore Sn is equal to, leave this one n as it is, because we have to find the sum of the first n terms. Okay, so n by 2 into 2 into, what is the first term? It is 9. Now we are talking about this sequence, not the quadratic sequence. First difference is this one. Okay, so 2 into 9 plus n minus 1, leave n as it is. What is the common difference here in this sequence? 12. So it is 12. So what is this one? Sn is equal to n over 2 into 2 into 9 is 18. Now expand the bracket. 12 into n is 12n. 12 into minus 1 is minus 12. Now it's a simple algebra section. So n over 2 into, let me write that one first, 12n. What is 18 minus 12? That is 6. So it is plus 6. Now we can expand this bracket. N by 2 into 12n. So what is that one? N into n is n square. So it is 12n square divided by 2. Then plus n into 6 is 6n divided by, don't forget that 2, divided by 2. N into 6 is 6n. N into 12n is 12n square. Then this divided by 2, this divided by 2. Okay, so what is the final answer now? Sn is equal to, 12 by 2 is 6n square plus 6 by 2 is 3n. Look at the question. Is it not that one we want to prove? 6n square plus 3n. And that is the expression to find the sum of the n terms of the first difference. This is the first difference. And what is the formula to find the sum of the n terms? Sn is equal to this one. Okay, so that is the question 2.2.3. Now let's move to the next question, 2.2.4. Question number 2.2.4. Question number 2.2.4. What is that question? How many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060? What's the meaning of that question? Yeah, it's a complicated English, so you have to cut it into pieces. Look at that question. And how many consecutive first differences were added to the first term of the quadratic number pattern? So here, which one is the first difference? This is the first difference. Am I right? This one is the first difference. Okay, this is the first difference. These ones. Okay, so how many consecutive first difference were added? So for example, what I mean is, to get this 27, this is the quadratic sequence. Am I right? Okay, excuse me, this is the quadratic sequence, this one is the quadratic sequence. Okay, this is the quadratic sequence. Now to get this 27, how many first difference were added? Look at this one, minus 3 plus 9, 6, 6 plus 21, 27. That means to get the third term, 27 is the third term, am I right? This is the first term, this is the second term, and this one is the third term, this is the fourth term. Okay, so to get the third term, how many consecutive first difference is added? 2 consecutive first difference is added, alright, to get the third term. You understand? To get the fourth term, how many consecutive first difference is added? 1, 2, 3. That means to get the fourth term, 3 consecutive difference is added. Okay. To get the third term, 2 consecutive first difference is added. To get the fifth term, 4 consecutive first difference is added. You understand? This is the first difference. Okay. To get to this 60, how many first difference? Consecutive means next to each other. Okay. How many first difference is added? 9, 21, 33. 3 first difference is added to get to this 60. Am I right? 3 plus 9, 6. 6 plus, minus 3 plus 9, 6. 6 plus 21, 27. 27 plus 33, 60. That means 3 terms of the first difference is added. Okay. Now, so let me write that quadratic sequence once more here. What is our quadratic sequence? Minus 3, 6, 27, 60, etc. Okay, that is the quadratic sequence. Okay, so now what is the question? Where is that question? Okay, so here this is addition. Okay, so let me write it like this, like addition. Okay, so minus 3 plus 6 plus 27 plus 60 plus etc. Okay, and here what is this one? First difference, 9 plus 21 plus 33 plus etc. Okay, so now you have to write, look at that question once more, how many consecutive first differences, were added to the first term of the quadratic number pattern, to obtain a term in the quadratic number pattern that has a value. That means there is somewhere here, there is a value 21,000. Quadratic pattern has a value, okay, 21,060. You understand? There is a somewhere here, there is a etc like this, this one etc, and plus, and there is a value 21,060. Okay, and you have to write, to get that 21,060, how many numbers must add? You understand? Okay, so to get that 21,060, how many numbers must add here? That is the meaning of the question. Okay, to get to this 60, how many numbers must add in the first difference? 1, 2, 3. To get the fourth term, you have to add 3 consecutive numbers, first difference. Am I right? To get the, this is the first term, like what I said there, this is the first term, second term, third term, this is the fourth term. Okay, like that, to get the third term, how many consecutive first difference to add? 2. To get the fourth term, how many consecutive first difference to be added? 3. Am I right? Like that, to get to this term, how many numbers must I add? Do you understand the meaning of the question? To get to this term, how many numbers must I add? You understand? Okay, so first of all, what we have to do is, we have to know what is Tn here. We have to call this one as Tn, 21,060. Okay, then you have to find which term is this one. What is the value of this n? You understand, guys? Okay, so here we already find a quadratic equation. What is a quadratic equation? First question, 2.2.1. What is a quadratic pattern? Tn is equal to, there we got a quadratic pattern, 6n square minus 9n. You remember, this is the first question, 2.2.1. okay, so here we can call this last term as Tn. Okay, so what is this one? Tn is equal to, that is 21,060 is equal to 6n square minus 9n. So take this one to the other side, okay, and let me write it here like a quadratic equation, 6n square minus 9n. Take this one to the other side, so it is minus 21,060 is equal to 0. Just to swap that one, that's all. Okay, okay, now from here we have to find the value of n. Okay, from this equation we have to find the value of n, so that we know that, okay, for example 50th term is this one, or 75th term is this one, like that. Okay, so how can we solve this one? We have to factorize, am I right? Okay, so here this is 3, say 9. Okay, all of these thing and these numbers are divided by 3. So let's divide by 3, divide by 3, divide by 3, divide by 3. So what is that one? Here 6 by 3 is 2n square, 9 by 3 is 3n minus, this is 21 by 3, 7, 6, 0, 2, sorry, what is that, that one? 7020, 7020. okay, 20 is equal to 0. So now guys, you have to factorize this one. Okay, so here what are the factors? If the number is too big, it's better to apply the quadratic formula. Can you see that here the number is too big? Okay, so we can apply the, or what is 60 times, we want 7020, so it is 60 times 63, 3000, 60 times, oh, here we have 2n square. Okay, just apply quadratic formula, guys, that's easy. Okay, so what is the quadratic formula? Minus b, what is b? Minus 3 plus or minus square root of, here I am not going to explain much on quadratic formula. Okay, if you don't know, those who don't know how to apply quadratic formula, you have to study algebra section, there I explain clearly. Okay, b square, so it is minus 3 square minus 4 into a into c minus 7020 divided by 2 into a, oh sorry, 2 into a, that is, what is the value of a? It is 2. So take your calculator, try to find the answer of that one. So it is 3 plus square root of 9 plus 4 times 2 times 7020 square bracket close divided by 4. There it is, one n value is 60, and what is other n value? I just want to change this sign to minus. So it is minus 117 divided by 2. So anyway, n means the number of terms, or which term is that. So it can't be minus 117 by 2th term. Okay, so what is the possibility? It means that the value of n is equal to 60. Do you understand? So now look at, it's not finished, that is not the answer. Now look at this one. It means that, what is the meaning of that 60? It means that, let me erase this one. It means that the 60th term is 21,060. Okay, am I right? Okay, the 60th term is here. Now we know that it is 60. The T60 is 21,060. Okay. Okay, so now can you say how many numbers in the first difference to be added? Like what I said before, to get the third term, how many numbers to be added? 2 numbers. To get the fourth term, how many numbers to be added? 1, 2, 3 numbers. So what about to get the 60th term? 1 less than that one, am I right? 59 terms to be added. Okay, to get the fourth term, 3 numbers. To get the third term, 2 numbers. That means 1 less than this, am I right? So similarly, to get the 60th term, you have to therefore 59 terms of the first difference is to be added. So 15, therefore 59 terms of the first difference. There are 59 terms you have to add to get this 21,060. Okay, I hope you understand that one. Okay, so that is question number 2.2.4. Now let's move to the next question, 3.1. Okay, now let's move to the next question, question number 3.1. What is that question, guys? Look at that question. Sigma k, prove that sigma k is equal to 1 to infinity 4 into 3 raised to 2 minus k is a convergent geometric series. Which one we have to prove? This is question number 3.1. Which one you have to prove? Sigma k is equal to 1 to infinity. This is a sum to infinity. Am I right? 1 to infinity means sum to infinity. 4 into 3 raised to 2 minus k. You have to prove that this one is a convergent geometric series. Am I right? Convergent geometric series. Show all your calculations. Okay. So now, what is the meaning of convergent geometry series? Convergent geometry series means you can find a common difference. Am I right? For example, let's say 8, 4, 2, 1, etc. What is the common? This is not a arithmetic sequence. It's a geometry sequence. Why? This is T1, T2, T3, T4, etc. So what is common ratio? 4 divided by 8. That is 1 over 2. Or 2 divided by 4. 1 over 2. So what is the ratio? 1 over 2 is the common ratio. You understand? So this one is a geometric series. Am I right? Okay. Now, in the case of a geometry series, if the value of r, if it is between -1 and +1, okay. So if the value of r is between -1 and +1, then we can say that this series is a convergent geometry series. If the value of r, if it is between -1 and +1, here you can see that what is the value of r here? 1 over 2. 1 over 2 means that is between -1 and 1. So this one is a convergent geometric series. Okay. So here we have to prove that this one is a convergent geometry. So first we have to prove that, or we have to find the value of r in this series. Okay, we have to find the value of r. So if that value of r is between -1 and 1, then it's a convergent geometry series. Okay, so how can we find the value of r from here? What is sigma stands for? The sum. Okay, sum from where to where? From 1 to infinity. So we have to expand that one. How can we expand that one? Is equal to, this one is equal to, we have to substitute the first k value as 1. That means 4 into 3 raised to 2 minus 1. What is 2 minus? Okay, let's write like that. Plus, after 1 it's 2. Then after 2 is 3, 4, 5, 6, up to where? Up to infinity. Am I right? Okay. So it is 4. Next one, 4 into 3 raised to 2 minus, next k value I am supposed to substitute as 2. 1 substitute, next 2. Okay. Plus 4 into 3 raised to 2 minus 1, 2, next one is 3. Plus etc. up to where? 4 into 3 raised to 2 minus infinity. 2 minus infinity is infinity. Am I right? So 4 into infinity is infinity. Okay, so here this is the series, am I right? Okay, and this is a geometry series. So it is given that this one is a geometry series. That is why, or how can we understand that this is a geometry series? If it is coming like this as a power 3 raised to, the variable is here as an exponent. Can you see that? Then this is a geometric series. So here we can find the common ratio. How can we find the common ratio here? Common ratio, second term divided by first term. That means T2 divided by T1. Am I right? So what is T2 here? 4 into 3 raised to 2 minus 2 is 0. Okay, divided by T1 is this one. So it is 4 into 3 raised to 2 minus 1 is 1. Okay, so here what is this one? This 4 and 4 cancel. Am I right? So what is 3 raised to 0? Any number raised to 0 is 1. Divided by 3 raised to 1 is 3. So what is the common ratio, guys? Common ratio is 1 over 3. Am I right? So now it implies that the value of R is 1 over 3. 1 over 3 means 0 0.3333. Am I right? That is definitely, it implies that minus 1 is less than 1 over 3 is less than positive 1. So it implies that minus 1 less than R less than 1. It implies that this series is a, you have to write here, therefore the series is a convergent geometric series. You understand? Okay, so this is all what you have to do. You have to find the value of R and check that R is it between minus 1 and positive 1. If it is like that, convergent geometry. If it is not like that, it's not convergent. That's all. Okay, so that is question number 3.1. Now let's move to the next question, 3.2. Number 3.2. What is that question? If sigma k is equal to p to infinity, so here it's p to infinity, sigma k is equal to, the previous one was 1 to infinity, this one is p to infinity. Okay, p to infinity 4 into 3 raised to 2 minus k is equal to 2 over 9. Determine the value of p. That means if it is like this, you have to find the value of, where is p here? Okay, that means this one. Okay, determine the value of p. That is the question. So anyway, we have to find this value of p here, we have to expand this series. Am I right? Okay, so look at this, sigma k is equal to p to infinity. So it means that starting, if it is 1, how we are writing? First 1, then 2, then 3, then 4, then 5, like that. Am I right? So if it is p, 1 more than this one, that's the second term. That means the second one is p plus 1. Then the next one is p plus 2. Next one is p plus 3. Up to where? Up to infinity. Do you understand? This is how you want to substitute the value of k. P here, first p here, then value of k is p plus 1, then p plus 2, p plus 3, like that. Okay, so this is the question. Okay, sigma k is equal to p to infinity 4 into 3 raised to 2 minus k is equal to 2 over 9. Now look at this one, p to infinity, sigma means sum. Am I right? So sum from p to infinity, sum to infinity. So this is a geometry series. Can you see that 3 raised to 2 minus k, that is a geometric series. Okay, so in the case of a geometry series, you studied a formula to find sum to infinity. That is, what is the formula? Do you by heart that one? A divided by 1 minus r. That is a formula to find the sum to infinity in the case of a geometric series. Okay, now look at the left hand side. Okay, I'm going to take the left hand side, LHS. So here what is that one? Sigma k is equal to p to infinity 4 into 3 raised to 2 minus k. Now we can try to expand this one. Okay, so what is this one? This is, first we have to substitute. What is the first p value? It is p. Am I right? I mean, first k value, first k value is p. Then after that, one more than that one. Am I right? In case if here it is 1, how you are substituting the values of k? First 1, second 2, then 3, then 4, then 5, then 6, like that. One more, like that. Okay. Similarly, here the first value is p. Am I right? So the next value is p plus 1. Next value is p plus 2, like that up to infinity. Am I right? So like that we can substitute the value of k. So it is not now we don't want to write a sigma. I'm going to expand the bracket. Okay, so it is 4 times 3 raised to 2 minus k. First k value is p, plus 4 times 3 raised to 2 minus, what is the second value? P plus 1. So it is p plus 1 plus 4 times 3 raised to 2 minus, what is the next one? P plus 2. One more than that, p plus 1, that is p. It is like this, p plus 1, one more than p plus 1, that is plus 1. So it is p plus 2. Okay, plus etc. up to infinity, because there is no need to write a 4 into 3 raised to infinity. 3 raised to infinity is infinity, so 4 into infinity is infinity. So it is enough to write a plus up to infinity. Okay, so anyway, try to understand this is the sum to infinity. Don't forget that one. Okay. Okay, now here let me simplify this one. One more step, then after that we can do something. Okay, so this is 4 into 3 raised to 2 minus p plus 4 into 3 raised to, what is this one, guys? If I expand the bracket, minus into p minus p, minus into 1 is minus 1, 2 minus 1 is 1, so it is 1 minus p plus 4 into same one, 4 into 3 raised to, if I expand that one, 2 into minus into p is minus p, minus into 2 is minus 2, so it is going to be cancelled and it is going to be minus p plus etc. plus up to infinity, sum to infinity. Okay, so now of course this is a geometry series, am I right? Like what I said before, 3 to the power of 2 minus k. Here the variable is k, so variable is coming as a power, so in that case it's a geometric series. Okay, so this is a geometry series. So in this geometry series, what is the value of a? What is the value of a here? A is equal to first term. First term stands for a. Okay, so what is the value of a? 4 times 3 raised to 2 minus p, that is the value of a. Am I right? Now what is the value of r? R means common ratio. How can I find second term divided by first term? Am I right? So it is 4 into 3 raised to 1 minus p divided by first term. First term, this is the first term, this is the second term. So 4 into 3 raised to 2 minus p. So this 4 and 4 cancel. Can you see it's the same base? So how can we write? 3 into, guys, a raised to m divided by a raised to n. How you are going to write? M minus n, that exponential rule. Okay, same applies here. 3 raised to 1 minus p minus bracket this one, 2 minus p. So 1 minus p minus into 2. I am going to expand the bracket. So minus 2 minus into minus is plus p. So here you can see this minus p and a plus p you can cancel. So what is remaining? 1 minus 2, that is minus 1. Okay, so this one is going to be, let me write the remaining here. So this is going to be, this is equal to 3 raised to minus 1. What is 3 raised to minus 1? That is 1 over 3. So what is the value of r, guys? We are trying to find the value of r. So what is the value of r? 1 over 3. 1 over 3 is the value of r. Okay, so here we got, this is r. Okay, so we got the value of a is this one from first term, and we got the value of r, that is 1 over 3. But what is this one? Sigma k is equal to p to infinity of a geometry, sum to infinity of a geometry series, and it is given that is 2 over 9. Can you see that it is given in the question that the answer for this one is sum to infinity is 2 over 9. Okay, so now sum to infinity, it is given as 2 over 9. That is the sum to infinity. Sum to infinity, that is 2 over 9. So in a case of a geometry series, we know the formula to find the sum to infinity, that is a divided by 1 minus r, and that is given as 2 over 9. So what we can do, now we know the values of a and r, substitute the values. Okay, so those who didn't write this one, pause the video and write a. So substitute the values there. So a, what is the value of a? 4 into this one. Okay, so therefore 4 into 3 raised to 2 minus p divided by 1 minus r, 1 minus 1 over 3. Am I right? 1 over 3 is the value of r, and it is given that that one is 2 over 9. So from there we have to factorize, or we have to solve this one and find the value of p. Okay, so now how can we find the value of p from here? So now look at the denominator. First we can solve that one. Okay, then after that we can do the remaining step. Okay, so what is 1 minus 1 over 3? Check in your calculator. 3 minus 1, 2 over 3. Am I right? Okay, so this one is 4 times 3 raised to 2 minus p divided by 2 over 3. You can check in your calculator this one. Okay, and that is 2 over 9. You understand? Okay, so here this is denominator, division. So if I want to take this one to the other side, it is multiplication. So it means that 4 into 3 raised to 2 minus p is equal to, already there is a 2 over 9 there, then I am going to multiply this 2 over 3 there. So times 2 over 3. You understand? Okay, so 4 into 3 raised to 2 minus p is equal to 2 times 2 is 4, 9 times 3 is 27. Okay, now look at this one. This is multiplication. So if I want to take this 4 to the other side, it is division. Division means it will come here in the denominator. Am I right? Okay, so 3 into 2 raised to 3 raised to 2 minus p is equal to 4 divided by 27 times 4. This 4 multiplication, it will straight come to the denominator here and multiply here. 27 times 4. So here 4 and 4 we can cancel. So what is remaining now? 3 raised to 2 minus p is equal to, cancel 4 and 4. So remaining here it is 1 over 27. 1 over 27 is what? 27 is 3 raised to 3. Okay, so 3 raised to 2 minus p is equal to 1 over 3 raised to 3. So if I take this 3 raised to 3 to the numerator, apply exponential rule. So it is 3 raised to 2 minus p is equal to 3 raised to minus 3. So now here we can see the exponent, bases are the same. So what we can do? We can equate the exponents. So it means 2 minus p is equal to minus 3. Take this minus p to this side and this minus 3 to this side. So it is 2, this minus 3 on this side, it is plus 3 is equal to minus p on that side, it is positive p. So 2 plus 3 is what? 5. So the value of p is equal to 5. So in this question, look at the beginning of the question. Determine the value of p. So what is the value of p we got? It's a 5. Okay, so yeah, that's a tricky question. It's a higher order question. Okay, so anyway, that's the end of November 2020 sequence and series questions. So I hope you understand clearly. Okay, so thank you for watching. Keep on watching, practice maximum number of questions. Okay, thank you. Bye.